So I'm going through some of the questions that was given to you for your review. Not all of them. If you have any other questions, just let me know, but I'll go through some of them. So here's a recent poll by American Automobile Club found that 30% of those surveyed are worried about aggressive drivers on the road. If 3 people are selected at random, what is the probability that all 3 will be worried about aggressive drivers on the road? So there are 3 people that we are picking. So there are 3 events that are happening. And we're looking for people who are worried about aggressive drivers. And it tells us that 30% of people surveyed are worried about aggressive drivers. So that means we're looking, so what are the odds of us picking someone who's worried about aggressive drivers? So that's 0.30, 30%. And it's 0.30 every single time. Because remember, when it's a percentage, you don't reduce anything. You don't take one away and act as though it is a dependent event, because there's so many people that we're taking here that taking one away does not really affect the percentage. And then when we have multiple events, we multiply them. So it's 0.027. And that will be the odds of you picking 3 people. Or if you want to put it as percentage, because on your test it won't be multiple choice, but you can write as percent if you want, 2.7%. So the odds of you picking 3 people who are all worried about aggressive driver is B. All right, the next one says a box contains blue chips and red chips. The person selects 2 chips without replacement. If the probability of selecting a blue chip and a red chip is 32 out of 128, and a probability of selecting a blue chip on the first draw is 5 out of 16, find a probability selecting the red chip on the second draw given that the first chip selected was a blue chip. So you will be given this formula. The probability of B given A is equal to the probability of A and B happening together, divided by the probability of the first event taking place, which is after the given, so it's divided by the probability of A. So you will be given this, and the thing that you have to be able to recognize is it says given. We're trying to solve for the probability of an event happening, given that something else happened first. So we need to look and see, do they tell us the probability of both events happening? Well, blue and red chip, it tells us here that the probability or the odds is 32 over 128. And then we have to divide it by the probability of the odds of the very first event taking place. In our formula, it's A, but if you look here, it says we want to find a red chip on the second draw given that the first chip was a blue draw. So we need to find a probability of selecting a blue chip, which they tell us here is 5 over 16. Right? Then you can plug this into your calculator, or you can reduce. I'll write it out for you. 32 over 128 will be multiplied. So we multiply by the reciprocal of 5 over 16, so it's 16 over 5. So let's see. 16 goes into 128 8 times. 8 goes into 32 4 times. So this is then equal to 4 over 5. All right. A furniture manufacturer offers bookcases in 5 different sizes and 4 different colors. If every color is available in every size, then the total number of bookcases is. So one way you can look at this is if we have 5 different bookcases in 5 different sizes, we have extra small, medium, large, and extra large bookcases. And they come in 4 different colors. They can come in black, they can come in blue, they can come in green, and they can come in red. So for each of these, we would have 4 bookcases that we can make of different colors, all for the extra small. So that means there's 4 bookcases for the extra small, 4 bookcases for the small, 4 for the medium, 4 for the large, and 4 for the extra large. If we add all these together, we would get a total of 20. However, it's not easy to do this if you're given larger numbers or you're given multiple things. But what you can think about is we have 2 different things that can happen here that we're looking for. We have our sizes and we have our colors. Well, we have 5 sizes and 4 colors. Well, this is 2 different events going on, and whenever we have multiple events, we can multiply them. So there are 20 different total number of bookcases that we can make that are 5 different sizes and 4 different colors. Right. In a Happy Hilltop Health home, 10% of residents play shuffleboard, 30% play poker, 50% garden. If 35% of residents play poker and garden, and 70% of the residents play both shuffleboard and poker, then find a probability that a resident plays poker given that they garden. So this is the key thing here. Again, it's given. So we need to use the formula, the probability of B given A. So we need to find a probability of both of them happening. So we need to find a probability that someone plays poker and they garden. Well, here they tell us 35% of residents play poker and garden. So we know it's 0.35 is in our numerator. And then it's divided by our second event, which I gave you the formula already in one of the earlier questions, and you'll be getting it on the board. So the second event, or I'm sorry, by the first event, A, so that means given that they garden, so we need to find a probability that they garden, which here is 50%. So we divide by 0.5 or 0.50, and that will then be equal to 0.70 or 70%. All right, so for this problem, it says a store manager wants to display 6 different brands of toothpaste in a row. How many ways can this be done? So what you need to identify is that we're not only displaying 3 of the 6, we're displaying all of them. And when we're displaying all of them, we need to use our formula of n factorial, because what can happen is we can have 6 different toothpastes that we are displaying. Well, before we display any of them, there's 6 toothpaste that we can put in this very first position. Once we put the first toothpaste there, then there's only 5 left, then 4, then 3 that we can put there, then 2, and then we're down to the last one. And when we have different events, we know that we can multiply them. Or you can just think, whenever you are rearranging or arranging multiple things and you're doing all of them, we can just do 6 factorial, which is what we did here with the 6 times 5 times 4 times 3 times 2 times 1. And 6 factorial is equal to 720. So that means there are 720 different ways that they can rearrange these 6 brands of toothpaste. Here it says a business has 7 locations to choose from and wishes to rank only the top 3. So we're top 3 locations. How many different ways can this be done? So once you see that we're not ranking all of them or rearranging all of them like we were to toothpaste, then we need to think about NPR or NCR, or permutation or combinations. And this is our permutation. And in this case, order matters. And this is our combination. And here, order does not matter. All right, so when we're looking at this, we need to see, well, we have 7 locations and we're choosing 3 of them. So, and it says ranking the top 3. So that means order matters. So that means we're going to be using our permutation. So you can just type it in your calculator. We have 7 total locations. We know we're using our permutation, so you can type NPR in your calculator. And then we're only ranking 3 of them. So we would then do 7 NPR3. And when we do 7 NPR3, we would get a total of 210 different ways that we can rank 3 out of the top 3 out of the 7 locations. So that would then be B. All right, now this one's a little bit different. It says Fizz soda comes in 2 flavors, regular and diet. If a researcher has 9 boxes of each, so it's 9 boxes of each, how many ways can he select 2 boxes of each for a quality control test? So this is telling us that we need to look at these separately, right? We have regular and we have diet, and we have 9 of each, and we're selecting 2 of them. And in this case, order doesn't matter because we're only picking 2. It's not we're ranking the best of any of them. We're just picking 2. So that means we have 9 total that we can pick for regular. We're doing combinations because order doesn't matter, and we're picking 2 of them. And we're picking 2 of each, so we need to do the same for diet because we also have 9 boxes of each. So that means we have 9 of diet. So we have 9. We're taking a combination of 2. And 9 combination 2 is going to give us 36. So we have 36 different ways that we can pick 2 out of the 9 for regular, and 36 different ways that we can pick 2 out of the 9 for diet. And when we have 2 different events that are going on, we're looking at regular and we're looking at diet, and now we're looking at how many different ways can we have combined. We need to multiply those. And 36 times 36 is 1,296. So there are 1,296 different ways that we can pick 2 of each, regular and diet. All right, now this is the last one, and it says 3 statistics professors and 7 chemistry professors are available to be advisors to a student organization. The student organization needs 2 of the professors to be advisors. If each professor has an equal chance of being selected, what is the probability that both professors are chemistry professors? So when we look here, since it says find what is the probability or what is the chance, what is the probability, we know we need to create a fraction. And when we create a fraction, we need to put the total number of possibilities on the bottom. So our total number of possibilities that we can have is we have 3 statistics professors and 7 chemistry. So we have 10 total professors, and we're selecting 2 of them. Order doesn't matter. It doesn't say that one needs to be first or one needs to be the president or anything. It just says we're picking 2, so that means it's a combination. So it's 10 NCR 2. All right, now in the numerator, we have 2 different events that are going on. We have statistics and chemistry professors. Well, we have 3 statistics professors. Order does not matter, and it says both of them need to be chemistry. So that means we are selecting 0 statistics professors. That's what we're looking at in this case because they want both of them to be chemistry. So that means of these 7 chemistry professors, we're taking a combination of how many can we pick of 2 of them? Well, 3 NCR0 is going to give me 1. 7 NCR2, so 7 combination 2 is going to give me 21. And 10 combination 2 is going to give me 45. So 21 times 1 is equal to 21. And 21 divided by 45 is going to give me 7 out of 15, which is 0.466 repeating. So 0.466 repeating, or 0.467 if we round. So that means A. So the probability of getting both chemistry professors is nearly 50%. All right, that is it for this video. If you have any other questions on the review, then make sure that you reach out.